Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to my brand new channel, where the adventure of learning begins. I'm excited to have you all here. Whether you are a student, a lifelong learner, or simply curious about the world, at Pathway to Engineering Degree, our mission is to provide you with an exciting educational content that will inspire, inform, and empower you. This channel is all about expanding your knowledge and exploring fascinating subjects and inspiring people to go to college, most importantly. If you're curious about the world around you and want to learn something new, then you already have a passion for engineering and you should probably consider studying it. Once again, I want to emphasize that this channel is for educational purpose only. It's a place where we will dive into different topics and explore various fields of study, gain valuable skills that will benefit us in school and beyond. So I encourage you to actively participate in our discussions, ask questions, share your thoughts in the comments section. Your engagement is what will shape the future of this channel. If you are a student and wondering if engineering is the right path for you, then follow this channel and maybe you'll find a satisfying answer, as I will be explaining from deciding a major to working on spacecrafts and rocket engines. If you find value in the content I provide, I kindly ask you to hit the subscribe button and become part of our growing community of curious minds. By subscribing, you'll stay up to date with our latest videos and never miss an opportunity to learn and grow. So thank you for joining me on this incredible educational journey. Together, let's expand our knowledge, challenge our thinking, and unlock our full potential. Again, welcome to Pathway to Engineering Degree. My name is Abdikarin Ibrahim. I am a recent mechanical engineering graduate, and I'm excited to share my experience as a student and professional engineer. In this channel, I'll be talking about the road to an engineering degree with a focus on mechanical engineering. I'll go over the courses I've taken in my undergrad, projects and internships, and my first full-time position as an engineer in the aerospace industry. I plan to discuss topics in each course I have taken and solve example problems in hopes to guide anyone interested in this field in my later videos. I'll also be open to making videos based on your requests, so pick your topics. We will start with mechanical engineering, or MECI, or some people like to call it ME. Then we'll do electrical engineering, aerospace, then civil. The rest will be based on request. So you might ask, what's mechanical engineering? Well, mechanical engineering is a branch of engineering that focuses on the design, development, manufacturing, and maintenance of mechanical systems. These systems can include anything from simple machines like levers, pulleys, to more complex machines like engines, robots, and even spacecrafts. Mechanical engineers use principles of physics, mathematics, and material science to design, develop these systems. They also work on improving existing systems and making them more efficient, cost-effective, and environmentally friendly, which are all very important points. So you might ask, what courses do students take in a typical four-year program in mechanical engineering? In the first year, students typically take introductory courses in math, physics, chemistry, and engineering. You won't really see engineering until your second year or third year. These courses provide a strong foundation for more advanced courses that come later. So what classes should you expect? Let's dive deeper into this. I went to school in Washington State, so this will be based on Washington State school system. In your first year as a college student, freshman, you'll take Calculus 1, you'll see Physics 1, you'll see Chemistry, Basic Chemistry, and Introductory course to Engineering. So what will you study in each of these courses? Even though we will explain each topic and what it will mean and go through every class that I personally have taken, let's just go through the simple things that you'll see. Some of the topics that you'll see in Calculus 1, Physics, or whatnot. In Calculus 1, you'll study the principles of calculus, including limits, derivatives, and integrals. We will explain what each of these terms mean in later videos, but for now, let's just take as it is. In Physics 1, students will study the fundamental principles of mechanics, such as motion, force, energy, and momentum. This is the heart of engineering. Mechanical, aerospace, this is what you'll do, but a bit more advanced. In chemistry, this covers the basics of chemical principles, including atomic structure, bonding, and chemical reaction. Some people might ask, why do you need chemistry as a mechanical engineer or aerospace? Well, I say to you, wait until you get to thermodynamics, where you analyze combustion system of car engine or turbine or how energy is created. Although they say energy is never created, never destroyed, technically you'll have to create power somehow. Next, you'll take introductory course to engineering. This course introduces students to the principal methods of engineering and different fields of study. This is where you'll sit in class and talk to your professor and say, what course or what field do I actually need to study based on my interest? This is the class where you'll probably figure out where you want to go with your life as an engineering student. In your second year, you'll also take English Composition 1 and 2. Most programs I've seen, even medical students, have taken Composition 1 and 2. In your first year or second year, you might take one in the first year and then the second one in the second year, but you'll have to take them before your third year. So in your second year, you'll take Calculus 2. This course covers the advanced topics of calculus, such as integration techniques, infinite series, and sequences. You'll take Physics 2, where you will study electricity, magnetism, and optics. You'll study differential equations. Not everyone takes differential equations, but I know aerospace, mechanical, and electrical engineering all take this class. And as a mechanical engineering student, this is probably the most important mathematics course you'll take in your career. Very important class. This course covers the methods of solving ordinary differential equations, including first-order differential equation, second-order equations with constant coefficients, and systems of equations. Students will study topics such as homogeneous and non-homogeneous equations, the Laplace transform, and numerical methods. In your second year, you'll study statics. You'll take 3 engineering courses as an engineering student. Mostly civil engineering, mechanical, and aerospace take this. Electricals don't take these classes. They'll take statics, dynamics, and mechanics of materials. In statics is the study of non-moving systems. Basically, like bridges, things that don't move. You'll analyze the forces applied to a bridge, for example, and you'll figure out it doesn't move. All forces must add up to 0. The sum of forces must add up to 0 in statics. That's how you know something is stationary. In dynamics, it's the opposite. It's the study of moving things. For example, engines, cars, aircrafts, anything that moves air. Those are dynamic systems, and that's where you'll study the introductory course for it. So these courses include the analysis for the analysis of forces, momentum, and motion. In mechanics of materials, you'll also study here the principles of stress, strain, deformation, and failure of materials. We're not talking about human stress, we're talking about material stress here. When you apply too much force onto a material, you're causing a stress, and it will probably deform and finally fail. That's how you analyze a material before you consider designing something. What material should you use for your design? Very important. You use statics heavily here, so pay attention in this class. You'll take general chemistry. This course covers the basics of chemical principles, including atomic structure, bonding, and chemical reactions. Students will study topics such as stereochemistry, gas laws, chemical equilibrium, acid-base chemistry. The laboratory component of this course provides students with hands-on experience in chemical analysis and synthesis. Very important class as well for thermodynamics. Let's just say you have completed first year and second year, and you're ready to you got into the program, and you're in your third year. You're starting as a mechanical engineering student in Washington State. Most students take material science. This course teaches students the properties and behaviors of materials, including metals, polymers, and ceramics. If you heard 1040 steel, stainless steel, carbon fiber, carbon disc, blah blah blah, all of these materials you heard, that's where you study all these materials. You'll study them in this class. For example, if you'll learn about what 1040 means. 1040 steel, carbon steel, is basically 10% carbon, and 40 is the industry serial number. That's what that means, and you'll learn much more of these. What that tells you a lot of things. It tells you about the strengths of the material. It tells you the whether it's a ductile or a brittle material. It tells you the temperature, thermal properties. It'll tell you chemical properties. It'll tell you a lot about it. So this is very important class if you're trying to become a material scientist or materials engineer, or even mechanical design engineer. Yeah, very important class. In third year, you'll take thermodynamics as well. Very important class. Students will probably study the principles of energy, heat transfer, and thermodynamics. Although there's a heat transfer course that you will take, let me explain something real quick. You will be in two different tracks at least in Washington State. You'll be in solid mechanics. For example, you'll take mechanical systems design 1, design 2, and mechanical systems design 3, or control systems. And then on the other hand, there will be fluids. So fluid mechanics, thermodynamics, and heat transfer. And then you'll take a class called thermofluids, or thermal fluids lab. So you will be in those two different tracks. Whichever you enjoy the most, that's where you will probably end up. However, when you graduate, you don't have a lot of choices. You'll take whatever job you can get just to get the experience. We'll talk about that later in the later videos. But let's continue on for now. So thermodynamics. In thermodynamics, you'll learn about energy, heat transfer, and thermodynamic cycles like refrigeration cycles and Carnot cycles and engine cycles and stuff like that. You'll study about 3D computer modeling and manufacturing processes. In this course, it covers the principles of manufacturing, including casting, formatting, and machining. You'll take mechanical systems design 1. Students learn about the principles of engineering design, including concept generation, analysis, and optimization. This is where you will start thinking like an engineer. They will show you a problem and ask you to find a solution. And then that's where concept generation comes in. And then you analyze by analyzing the forces. You do FEA analysis, finite element analysis, whether the material you chose will satisfy the job. If it's not, then optimization comes in. You optimize it, and then and so on and so on. You never get it right in your first design. Nobody does. I wouldn't say it. If you're senior and you have the experience, you'll probably get it because you know what you're doing. But as a student, you don't get it right in your first design most of the time, unless you're a genius. And then you'll take fluid mechanics. Fluid mechanics, you'll study fluid flow, including fluid statics, fluid kinematics, fluid dynamics. This is where you learn about computational fluid dynamics software, where you analyze the fluid flow of a moving car, aircraft wing, anything moving in the air. There's a lot of fluids. We only think when people talk about fluid, we only think about water and all the basic aspects. But air is fluid, electricity is fluid, honey is fluid. Anything that flows is fluid. So, and you'll learn all of those in this class, not just water and the basic things you that comes to mind. You'll learn about laminar flow, turbulent flow, and the difference between Newtonian and non-Newtonian fluids. In your fourth year, students usually take advanced courses in areas such as robotics, aerospace engineering as an elective, energy systems. You may also have the opportunity to work on a senior capstone project. This is requirement for Washington, at least for Washington University of Washington specifically. It's a requirement for you to graduate to do a complete senior project, which involves designing and building a complex mechanical system and testing it, of course. Then you'll take control systems, which is the series of mechanical systems, design 1, 2, and then 3. Design 3 systems, design 3 is control systems. When you design something, you also have to learn how to control them. You'll learn about feedback control, system modeling, and simulation in this class. You'll use MATLAB in this course, or some other simulation software, or you'll do very basic programming as well. You might use MATLAB, or you might use Python, or different software to basically get through this class. You'll also, in your senior year, you'll probably be in a team to design and test a mechanical system. That's your senior design. This is if you're lucky and you've done all your classes early on and you have a couple quarters to spend. This is where you take elective courses. Maybe you want to go to graduate school after, or you just want to expand your knowledge. Some people basically make a career out of it from the classes they have taken in their elective courses. So don't. This is very important, and choose them carefully as well. You can take a variety of electives such as advanced topics in mechanics, material science, control systems, robotics. In robotics, you'll probably learn about robotic systems, including kinematics, dynamics, and control. In aerospace, you'll learn about aerospace systems, including flight control, for flight dynamics, aerodynamics, and propulsion systems. In energy systems, these are all elective courses. You'll take energy systems, including renewable energy, power generation, and energy storage, like solar batteries and all that stuff. Throughout the program, students will take advanced courses that are very integral to their career. But you'll also have to, don't forget, you also have to take some ethical courses. Communication courses, because of course you need to be able to communicate as a professional engineer, which will help you develop skills that are essential for success in the engineering profession. So what can you expect from a career in mechanical engineering? Well, mechanical engineering work a variety of industries, including aerospace, automotive, energy. You can work in manufacturing. You can work in naval design and weaponry systems and military work. You could be doing medical work, like medical industry. There's no limit for mechanical engineering. I've seen mechanical engineers working in a bank doing all the math. So don't be surprised if someone offers you something you haven't thought about was a mechanical engineering job. They can work in research and development and design, testing, and maintenance of all mechanical and non-mechanical systems. They're always in high demand and typically earn a great salary. That's a fact. In conclusion, I'll tell you right off the bat, mechanical engineering would set you up for success if you study it with understand it. I also want to emphasize in your first 2 years, it's very important that you pay attention to all your basic classes, because your third year and your fourth year, you'll be forced to pay attention, because then you will see the whole point of studying and becoming an engineer. When you really start doing real engineering work, analysis and engineering work in your projects, that's when it hits, and then you'll love it. Once you have the passion for it, then you don't need the motivation. It comes in naturally, believe me. So your first year and your second year, you don't really see the whole point of it, other than just doing a bunch of mathematics and physics and engineering homeworks. But in your third year, in your fourth year, that's when it all hits, and that's when you see the future out of it. So my advice to you is your first 2 years are the two most important years of your college career. And after that, you'll be set, because if you understand, if you pay attention, you'll be in those classes anyway, so you might as well pay attention. Once you go through all those classes and you get to your third year, you may not enjoy all the courses you have taken, but for sure in your third year, you will find your best suit, and you say, you know what, this is what I'm going to study, this is what I love to do, and this is where I'm going to go with my career. And that's the whole point of it. You could in your third year and your fourth year, every class you basically take, you can make a career out of it. You can specialize and just do that class. Literally, you can be doing thermodynamics and analyzing energy systems. You could be designing turbines and car engines, and those are thermodynamics work. You could be doing HVAC systems like heating, ventilation, air conditioning. Those are great things to design. You could be doing control systems and just be a control engineer or automation engineer. You could be doing anything. You could be mechanical systems design. You could be material scientist. You could be materials engineer. Anything you take in your third and fourth year in mechanical engineering can be a major of its own. But you don't really see the whole point, or you don't, until you get through your first 2 years, you don't see those basically, you don't get to that. So that's why I said your first 2 years are very, very important, and you pay extra attention in all those classes, because you don't know which one you'll enjoy once you get to your third year. And if you didn't pay attention in the right class that you will probably enjoy, then you wasted your time. I'm not going to say you wasted your time, but you're just going to say, oh, I wish I paid attention. So that's the conclusion of this video. In the next video, we'll talk about electrical engineering. In this mechanical engineering journey, we'll dive deeper into all of these courses, basically what calculus teaches you. We'll take topics and basically explain what it is, give example problems, and my whole point of this channel is to show you basically, I just want to inspire you and then show you and give you hope that you can also study these programs. These are really great programs. Engineering is basically it's a way of living. Once you study engineering, you basically have created a way of living for yourself and for your family and for your whoever, your loved ones. So my whole point of this channel is really to inspire other people, and hopefully they can take the same path or different path or whatever and become engineers. I love to see that in the engineering world. New graduates, people who are energetic and interested in learning something new, and with the right attitude, you can go really far. See you next time. Thank you very much.